In this part of the lesson, we'll look at standardizing, which is what's going to happen to your VCE scores at the end of the year, and the 68, 95, 99.7 rule. So for any normally distributed random variable, approximately 68% of the values lie within one standard deviation of the mean. So basically, the area under the curve between -1 and 1, in this case, this is the standard normal distribution, so mean of 0, standard deviation of 1, so this is 1 to the right and 1 to the left, is 68%, or has a probability of 0.68. So that's what the chances are. Alright, now 95% of the values lie within 2 standard deviations of the mean. So over here, this area here is roughly 0.95. Okay, so 2 standard deviations to the left, 2 to the right. And finally, 99.7, or almost all of them, lie within 3 standard deviations of the mean. Okay, so we can see there that the area under the curve is 0.997, so almost 1. Okay, we can try this out if you're really interested, so I am. I want to grab my standard normal, and I'm going to get the area under the curve of the standard normal between -1 and 1. So that's this curve here. I want to find out what the area is, and I'm hoping that the area is roughly 0.68. Let's find out. There it is there, 0.682689. So we say that roughly 68%, but more exactly, it's going to be something like that, okay, if you want the exact number. Okay, and you can guess, I'm sure, that if I extend this out to 2 standard deviations, we've got 0.95, and let's do 3 standard deviations, 3 and -3. 0.997. Okay, now that means that basically I'm going to be really close to all of the values if I put 4 and -4 here. Let's see what I get here. 0.9999. Okay, so I've got almost all of them by 4 standard deviations. So really, you saw here that in this one here I went from positive infinity to negative infinity is 1. But from -4 to 4 on the standard, I've almost got all of the values already. So that's just something of interest, I suppose. Right, if we break this up, we can see that roughly 68% fall either side, or half. So if we go 1 standard deviation to the right, that's 34%, and 1 standard deviation to the left is also 34, because 34 plus 34 is 68. And we can extend this up further, and we can look at these values here. If we add another 13.5 and 13.5, we get 2 standard deviations to the left and right, and another 2.35 and 2.35, and we get 3 standard deviations. Okay. Now to work out these extra values, all that we've done here is 2 standard deviations is 95%. So if we remove these values here, so 95 take away 68, what we're left with is, I'm doing some quick mental maths here, 27. Okay, that's going to be 27. So this bit here and this bit here in total must be 27% of the values. And because it's symmetrical, all I can do is do 27 divided by 2, which is 13.5. So that accounts for 13.5 to the right and 13.5 to the left. Okay, and similarly, these 2.35s are obtained by removing 95 from 99.7 and then halving the result. So that's how this diagram was generated. Alright, so inwards, 68%. Okay, if we had a probability of 0.68, well, don't know really what to comment on that, but by the time we get to 95%, if I said to you, I'm 95% sure that something's going to happen, you'd be like, oh, that's most probably, or most likely. And if I said to you that I'm 99.7% sure, then it's almost certainly going to happen. So that's how we would sort of equate those ideas. Right, so here's an example. Scores obtained on a VCE subject can be assumed to be normally distributed with a mean of 30 and a standard deviation of 7. Now remember, what happens is for some subjects that's not going to happen, and that's how they use statistical moderation to get it to fit this idea. Okay, approximately what percentage of the distribution lies within 1, 2 or 3 standard deviations of the mean? All right, so what we'll do is we'll just quickly draw this. All right, so here is my axes. Well, I probably shouldn't put the x-axis on there. Actually, I'll get rid of this. Right, and all I'm going to do is plonk the mean, which is 30. 1, 2, 3 to the right, 2, 3 to the left. That's 37, 44 and 51. 23, 16 and 9. Alright, so the bell curve, let's give ourselves a target. Has to look something like this. Now it should be symmetrical. Okay, mine's not, but this is just giving us a quick idea of it. So I know that within 1 standard deviation, okay, I know that 68% of students for any subject are going to fall between study scores of 23 to 37. I know that 95% of students are going to fall between 16 and 44, and 99.7 fall between 9 and 51. Hopefully you're on the 51 side. Alright, so the total area under the curve is 100. Okay, so all of the students fit somewhere here. Okay, but there will be some students who sit somewhere up here. Okay, very few. Okay, in fact, roughly, if 99.7 is 3 standard deviations, then it's 0.3% fall outside these 3 standard deviations. So below 9 or above 51. So for the example, 95% of the scores in the VCE study score distribution lie between 16 and 44, that is within 2 standard deviations. What percentage of the distribution is more than 2 standard deviations above or below? Okay, so what we want to know, I'm just going to grab some shading here. Let's change the color to something more visible. So here is the mean, 1, 2. So I want to know what area this is and what area this is. Okay. No, that's not the one. It should be 2 standard deviations, which is this one. Okay, so to answer this question, I basically will go all of the values, 100%, remove 2 standard deviations, which is 95% of the cohort, means that we've got 5 left over. Okay, and so that means that both of these bits here, this one here and this one here, equal 5. And that means that individually this will be 2.5 and this will be 2.5. So what that means is roughly, in any VCE subject, 2.5% are above 44 and 2.5% are below, what was the value? 16. Okay. Alright, so these are good questions to kind of test your understanding here. So always draw a picture, okay? And I'll show you what I mean by picture because it can be pretty dodgy. If X is normally distributed, okay, so that's important to know, and the probability that a random variable less than a particular number, A, is 0.2, and the probability that a random variable is below another number is 0.7, we want to find out what the chances are of it falling between A and B, and less than A, given that I know it's less than B. Excuse me. Okay, so let's draw it. So all I'm going to do is draw a normal distribution curve. Not bad. Alright, and I'm going to create a value A so that less than it has roughly an area of 0.2. Okay, and there's no science to this, but here's where I'm going to put my value A, because I'm going to claim that this area here is 0.2 or 20% of the values. Now it's complete guesswork here, but it's based on me knowing, I suppose, that this bit here is the mean, okay, and below the mean lie 50% of the values. So if I was to shade this bit here, okay, that is 0.5. So all I've done is shaded a bit less than 0.5. So here's the value I chose. All right, now let's put a b value in. The chance of the random variable being below b is 0.7. So that's higher than 0.5. So I'm going to put it somewhere over here, b. Draw that with different color shading. Green, let's go. So this bit here, the green, is 0.7. Alright, so now to answer our questions. So what's the chances it's between A and B? So I want to find this area here. Well, if I know that B is less than B is 0.7 and less than A is 0.2, then that's going to be just 0.7 take away 0.2 is 0.5. So this bit here must be 0.5, 50% of the values. Okay, what are the chances of being less than A given that I know it's less than B? Well, that's 0.2, so it's less than A is 0.2, and I know it's conditional probability, so I know that this part has happened, so I know that that's going to be 0.7, which is 2 sevenths. Can't leave decimals over, or a decimal fraction. Okay, let's try this one. If x is normally distributed and x greater than a particular number is 0.16. So again, I'm going to draw this now. So grab a line and just draw a fairly dodgy normal distribution curve. So 0.16. So remember, I basically know that that's 0.5, the mean. So I'm just going to put it somewhere here. So that's going to be D, and I'm going to shade this part here. That's 0.16. And between C and D is 0.59. Okay, so here's D, and let's put C in here somewhere. And this part here, let's change color. That part there is 0.59. So find the probability that the random variable is less than C. So we want this part here. So all that's going to be is all of it, 100, take away these percentages here, or these decimals here. So we're going to do 1 take away 0.16 plus 0.59. And that's going to be 6975, 0.25, I think. Yeah. Alright, an approximate answer for Z if probability that the random variable is above D is the same as... So basically they're saying, okay, we've got this distribution here, whatever it is, okay, what would it look like above what value on the Z distribution would this be the case? So again, what this is basically saying is, okay, go and imagine the Z distribution, and we want to know for what value is it going to have an area of 0.16, okay? All right, so these are a little bit trickier here, but let's just quickly draw the Z distribution. So the way it works is we've got the mean, 2, 3, oh. Not much better. Okay, so they're saying above what value on the Z distribution is going to produce an area of 0.16. All right, well, what do we know? We know that this part here, between one standard deviation to the left and right, that's 0.68. All right, that leaves either side of this, so this bit here and this bit here, to not be 0.68. So what's not 0.68? That bit and that bit is going to be 0.32. Now what is 0.32 halved? 0.16. Aha. Okay, so basically I know that if both of these parts are 0.32, this part only is going to be 0.16, which means basically that it is above 1 standard deviation. So approximate answer for Z, it's going to be when it equals when Z is equal to 1. Okay, and let's just test it. So what I'm going to do, this still is the standard normal distribution. Okay, and I'm going to leave positive infinity there, and I'm going to put the number 1 here, and what the answer should be is roughly 0.16. Yep, rounded to 2 decimal places, and it is. Alrighty, so standardizing. So the standard deviation can tell how well a student has gone in a particular subject. If they got a 37 for a subject, this puts him in the top 16% of the state. Okay, and if you got a 44, you're in the top 2.5. So the standard deviation is really, really important when looking at a normal distribution. Okay, and what we do often is to standardize, we kind of, in a way, compare apples with apples. Okay, so we call these standard values Z values. Okay, so to standardize, what we do, we first subtract the mean of the normal random variable from each score and then divide the result by the standard deviation. So why do we standardize? Okay, it's to compare different distributions more easily. And we often do it because there's a question that will ask us to find an unknown mean or standard deviation. More on this one later. So to compare different distributions more easily. So just say your friend says to you, you did a test in maths or something like that, and your friend says to you, I got a mean of, my score was, let's just say 62. And so this is the friend score, and you got a score of 55. Okay. Now your friend says, I did better than you because I got 62 and you got 55. Well, what I'd really want to know from the friend is what was the mean and what was the standard deviation. Okay, and I would use those two things to then compare the scores, because who knows how the subject went. For example, you might have got a 55 where the mean was 50, which is fantastic. Your friend might have got a 62 in a subject where the mean was 80. Okay, so these values here, the mean and the standard deviation, will help us work out how these scores compare to the center. Okay, and the standard deviation helps us compare the spread, so how widely spread the values were. Okay, so let's try it out. So Susie obtained results in 2 subjects as shown below. Okay, so in art history she got a 70, and in politics she got an 85. Now the mean of art history was 60, and pol was 73, and the standard deviation for the subjects were those. Alright, so what we'll do is find the Z of art history, which is you take the mark, you remove the mean over the standard deviation. This will give us what we call the Z score. Okay, so this is going to be 10 over 4.5, which is 2.2 recurring, it looks like. Okay, so that means that she sits just above 2 standard deviations to the right of the mean. It's a very good score. Okay, so let's try politics, which is 85. Sort of outward appearances say that this looks like the better result, but let's just see whether it is. 85, take away the mean over the standard deviation. So that's going to be, what, 8 over 5.4, 1.48. So what this means is that she would sit in this subject roughly 1.5 standard deviations above the mean. So this is the much better score. Okay, so I'd say that Susie went better in art history. Okay, and this is what's going to happen to your subjects this year, is it's all completely cohort driven. Okay, so the marks you get all depend on how everyone else went. Okay, the mean and the standard deviation. Okay, so in summary, this is the formula that I just used. Okay, this one here. So positive z-scores indicate a value above the mean. Negative means it's below the mean. For example, a study score of 23 lies below the mean and has a standard value of -1. Okay, so 23, take away 30, which is the mean study score, over the standard deviation, so -1, one below the mean. Alrighty, so hopefully that has given you an insight, 1 into the VCE, but 2 into the standardizing process. Good luck with 16B.